Hey everybody, this is Larry. This is day 14 of the February Leetcode Daily Challenge, which means it's Valentine's Day, so happy Valentine's Day for y'all out there. And hopefully, you get what your heart asks for, and maybe that is just to love and to be loved, the simple but not easy things in life. But alright, before we start, let's and you can fast forward this obviously, but buddy of mine on the thing. So I want to go over this about this technique on the contest ranking. I actually talked about this a little bit during some contest videos, so it'll be kind of interesting to just kind of bring it here on the daily thing, so we could talk about it a little bit. But yeah, but basically the idea here, this is nowadays there is a new-ish thing. It's been like a couple of months now, maybe. I don't know the exact timing. But basically on Leetcode contest, if you haven't done it recently or before, and I always advocate for Leetcode contest. I talked about it a couple of days ago, so hopefully you watch every video and then I don't have to kind of repeat things. I don't even remember when, so I need to label these things maybe. But in any case, yeah, if you do that, then you have done Leetcode contest the recent months or weeks or whatever it is, you'll notice that there are now part 1 and part 2s of these problems, meaning that there's a easier problem and then a harder problem. They're the same problem, but maybe the n is like 100 or 1,000, something small for part 1 and then bigger for part 2. And this actually comes, like it happened in Code Force pretty often. I don't know how often, haven't done it enough to tell you, but definitely also in the DMOJ's YAC contest, yet another contest, right? I think that's what it stands for. Written by Josh, whom I always will appreciate the contest. It's very well written in general, and I always like the problems and makes me think in a way that like, wow, it is interesting. So definitely check that out. Maybe if you ask for it, I'll put the links on the comments or the description. But yeah, so there are a couple of things. So there are now part 1, part 2s. But anyway, so because of the unique-ish, I don't know how unique it is anymore, because Leetcode just tries to be other contest sites these days for better and or worse. Yeah, so now they're part 1, part 2s, but because of the way that the Leetcode contest penalties work, so there are a couple of things that you can do. For example, if you're still learning, I would still advocate that it doesn't matter, right? Just solve all the problems in order that you get them. Worry about all these strategies a little bit later, but it is fun to think about in general. And I would also say that, and I said this even today on my Discord channel, on my Discord channel, where like, you have to figure out what your goals are, right? Is your goal to get better at problem solving? Is your goal better to get better at algorithms? Is it better to get a job, get an interview, and all these things, right? You have to figure out what your goals are. Yeah, the Leetcode rating or whatever is a kind of a proxy for your skill, but it's not perfectly matched, and it's not, right? So like, there are minor things that kind of, fluctuate while, there's some volatility there, up and down, and yeah, but like, if you improve your skill, your rating will go up. But if you improve your rating, it doesn't always mean your skill is caught up. And, if you're really honest with yourself, you will probably find that. Like if you find yourself Googling something during a contest and just copy and paste, like, yeah, okay. Like, maybe that's not technically cheating, and maybe, you get it right, and, stuff like that. And for the record, I actually don't have anything against Googling, especially for contest purposes, but I'm just saying that's an example of like, okay, this is a way to improve my rating, but what is your real goal, right? Is your real goal to, learn and to be better? Then it doesn't really help you do that, right? And one reason that I like about contests is that it's just so, for me anyway, because I'm only judging myself, I don't care about whatever, right? Is that for me, it is very pure in that you either do it or you don't. There's no forgetting how long I spent on a problem. There's no like, oh, if I was better, I could have done, yeah, okay, fine, I could say it, but at the end of the day, everything is just concrete in the system. Everyone know the rules, and you gotta do, you just gotta solve the problems and do it as fast as you can or whatever it is, right? So with all that caveats aside, like I said, this doesn't apply to most of you, but I just find it fun and amusing in terms of like, like game theory, right? Like in a game theory kind of way, I always kind of have I always find these things interesting, and sometimes I like to bring it up on these channels, especially on problems that people keep telling me is easy. I don't know. It's been a easy week, so maybe today it's not, but we'll see. But yeah. And anyway, so in a game theory kind of thing, there's a fun strategy that I've used a few times, to be honest. And you may say that's cheating, and maybe that boosts my rating. I don't know. I think I've done it 40, so I don't know if it has, but or like the one time that I did get a wrong answer, I did not use it. But the idea here is that okay, there's a part 1, part 2, right? You write the lazy brute force part 1, because at least so far all the part 1s have been just kind of like lazy problems that are brute forceable, meaning that you can write them with like a couple of for loops. Maybe you have to like think about it in a slightly better way so that it's not like n cubed, it's n squared instead of something like that. But it's just like for loops, right? So you can do that without, at least with practice, at least at my level, I suppose. But even for a lot of people not my level, it comes up where that you should just solve it with brute force, right? And then the cool thing is that there's a strategy in that, well, for the harder problem, usually, for the harder part 2, there is some optimizations that, or assumptions or observations or tricks that you have to figure out to scale this from n to 1,000 to 1,000,000, right? Or whatever the number is. And the hard part is not whether it runs fast enough. I mean, sometimes it is, but like it is based on, at least in general. So this may not apply to every problem, but it's not whether it'll be fast enough. Of course, if n is equal to like 1,000,000, you choose an n, or you choose an algorithm that's O of n or n log n, but it uses some simplifying assumption or observations and stuff like that, right? So something that makes the problem easier or easier to complexity wise, or faster complexity wise, because you made that observation. But that observation may not be right, especially since, a lot of things that you've seen could be greedy. And we've talked about this a lot, at least for myself. I'm really bad at greedy problems, right? So one trick that I can do is that, okay, I wrote some code, maybe it's greedy, so that is linear, but I don't know if it's right. And the normal course of things would be that I just submit it. Well, if it's wrong answer, then I know it's wrong. If it's right answer, I know it's right, right? Or, well, there is system testing, which we're not going to get into today, right? But yeah, if you submit it, okay, pretend it's right? But of course, if you get it wrong, if you submit it and it's wrong, it's like, oh, greedy doesn't work for this one case. So then you get a 5-minute penalty, assuming that you later solve it. So there is a strategy in which you take that part 2 and you submit it to part 1. And when you submit it to part 1, what happens is that because you already got an AC or an accepted result, every submission after that accepted result actually doesn't count toward penalty, whether it's correct or not. Well, I guess if it's correct, it shouldn't, but anyway. But yeah, so that means that if you get a wrong answer on some basic case, you actually do not get a penalty. And especially for greedy problems, that actually comes up, right? And also, let's be frank here, with n is 1,000,000, if you get some like weird, if you get a weird big case, like if you have n is equal to 900,000 elements and you fail on a greedy and not timing out, you're not going to debug it anyway. What are you going to do? How are you going to debug this, right? So it actually makes sense to take that code and solve it on a smaller problem, or submit it on a smaller first, because there's no penalty, it's free. Okay, fine. It takes a couple of seconds or whatever, so okay. But like practically free for a 5-minute risk, right? And of course you can define your own risk, but or your own confidence about it, but still. So that's one strategy that people have been talking about on my Discord. So definitely join the Discord if you're. I'm not good at ads, right? And it's not. I don't make money off Discord. I just like to talk to people. But yeah, we've been kind of talking about that strategy. And here, LeBron James of LC, were really like that picture looks like Popeye, kind of. Like that little icon looks like Popeye, like the Popeye. I can't do a Popeye face, but okay. Anyway, I digress. But yeah, now there's apparently a second part to this strategy, or like an additional part of this strategy. I guess what I just talked about is part one actually, but part two is that is the reverse, which is maybe more applicable if you're on the beginner's level. Is that because you only get a time penalty if you fail or if you later submit the problem correctly. So if you don't think you could get Q4, or if you don't think you could get part two, then you could actually take your if you don't think you could get the part two, you could take your part one solution and test it on part two. And if if it times out, that means that probably you're and this is actually what they're saying. So I actually didn't read it that much. I think as soon as I heard of this, I was like, oh yeah, it's obvious. Or like, I didn't think about it, to be honest, right? Is that, yeah, if you get a wrong answer, that means, well, it's going to be a wrong answer in part two, and then you could take that test case and debug it. If it's time limited, then yeah, then you're taking too long, and that should be because you're doing a more naive solution. And at the very least, you have an increased confidence, assuming a few things. I don't know, right? Like there may be some nuance that gets changed in the future, but yeah. But yeah, that's pretty much it. So definitely things to kind of, at the end of the day, does it change your skill level? No, like I said, it doesn't change your skill level. But it is a fun thing, a fun game theory thing. It'll improve your rating because, well, it just kind of decreases your wrong answer, the number of wrong answers that you get. So yeah. Anyway, that's all I have for the intro. It's a very long intro. Wow, I've been talking about this for 12 minutes. Sorry, friends. But yeah, let's actually get to today's problem. Thanks. Props to LeBron James of LC for kind of bringing it to my attention. And of course, today I would do the extra problem as well. Extra problem that I haven't done before, so stay tuned or hit the subscribe button for the next problem. But yeah, all right, let's take a look. Today's problem is 2149, rearrange array elements by sign. Excuse me. Oh, jeez. You're given a zero index array. Nums of even length consist of Leetcode numbers of positive and negative integers. You should rearrange the elements of nums such that the modified array follows the given conditions. Every consecutive pair of integers have opposite signs. Okay. For all the integers of the same signs, the order in which they present. Okay. Yeah, so it seems like there's I don't know if you could call it sorting. And it begins with a positive. Okay, I mean, that becomes pretty straightforward, though. I mean, basically, the thing to note is that, I want to say is that if you have a linear idea, like, you don't really have to worry about time or space in general, or constants. That's why, as soon as I have a linear idea, I'm like, all right. And the idea here is to separate the positive and the negatives, and then just kind of zip them back together, right? And that should be pretty much it. I mean, I don't really have to, like, the filtering is going to be linear, and then the combining is going to be linear, so I don't really have to worry about it. So let's get to it, right? So maybe I would have two things. So positive is equal to negatives is, and maybe, yeah, there are a couple of ways you can write this. You could also write this with a deck, is what I was thinking of, so that you could keep on popping from the front. But I could also just use zip, so it's not really a big issue, right? So if x is greater than 0, is then exactly 0? Is 0 positive? Oh, okay. Yeah, 0 is not part of it. I mean, I know that sounds like a silly question, but I don't know. Some problem setters are a little bit weird in general, and I've experience of a lot of them. So like sometimes I just like, things that are obvious to you, they think that they're doing something cool and new. So I don't know. Right, so then now for P, N in zip of positives, negatives, and we can do this easily because they have exactly the same number of positive and negative. I think, I wonder if there's a one-liner for this, to be honest. But maybe not, because I think maybe it comes up as a tuple. I mean, there may be one, but I don't know if there's a clean one. Like maybe you could do something like unrolling a tuple and like a flattening a list of tuples, but that's, I don't know. I mean, maybe that's a thing. But that just, that does not roll off my tongue, I guess. What did I do? This is during the contest last time I did, and I did the same way actually. Wow, the code looks actually exactly the same, except for I kind of changed the if statement. So it looks like, yeah. Anyway, this is linear time, linear space. Both are kind of the lower bound because, well, you have to look at every element and the return size is linear. Yeah, I don't know if you can, maybe there's a way to do it with constant extra space, but I'm not going to think about it. Anyway, that's all I have for this one. Let me know what you think. I mean, maybe there is some like whatchamacallit. Like if you really, I don't know if there's an easy way to do it, but maybe there is a lazy way to do like some sort of whatchamacallit, like almost like a Dutch flag kind of thing, algorithm, but to keep it all one, but I don't know. I mean, I think you could do it, but I'm not going to think about it. So that's all I have for today. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.